The Caribbean large igneous province consists of a major flood basalt, which created this large igneous province. It is the source of the current large eastern Pacific oceanic plateau, of which the Caribbean-Colombian oceanic plateau is the tectonized remnant. The deeper levels of the plateau have been exposed on its margins at the North and South American plates. The volcanism took place between 139 and 69 million years ago, with the majority of activity appearing to lie between 95 and 88 Ma. The plateau volume has been estimated as on the order of 4 by 106 cubic kilometers. It has been linked to the Galapagos hotspot, Proto-Caribbean Seaway. Divergence between the North American and South American plates began to create oceanic crust off Colombia's Pacific coast by the end of the Jurassic. This divergence, which continued until at least 66 Ma, first resulted in a Proto-Caribbean spreading ridge between these plates flanked by a perpendicular transform zone on its Pacific side. By 135 to 130 Ma, the subduction of the Farallon Plate had begun along this transform zone, effectively modifying it into a subduction zone and beginning the creation of the Great Caribbean Arch. This arch was formed around 120 to 115 Ma but must have been intersected by the Caribbean spreading ridge until 66 Ma. Hence the Farallon Plate fed the spreading zone and later became the Caribbean Plate. Lip formation. Clip formed as a large igneous province and now forms a thickened zone of oceanic crust between the North American and South American plates. In some places the oceanic crust is 2 to 3 times as thick as normal oceanic crust versus 7 kilometers. Its composition is similar to that of the Ontong Java Plateau. Geochemical and geochronological evidences clearly indicate that the Galapagos hotspot initiated the formation of the clip 95 to 90 Ma in the eastern Pacific. For there it moved northeast with the Farallon Plate between the two American plates until it collided with the volcanic arc. The Greater Antilles 60 million years later. Fragments of this voyage is preserved in accreted seamounts along the Central American coast and the Cocos and Carnegie Ridges. Isotopic profiles of Galapagos rocks can be matched with those from clip rocks. 92 to 63 Ma 40 R 39 R ages have been reported for the Curacao lava formation and 94 to 83 Ma for the Dumaso formation in Haiti, dating both locations back to the original lip formation 94 Ma. Clip volcanism originates from the plume-like source distinct from a MORB mantle. The long duration of clip volcanism can be explained by the interaction between a plume and the Greater Antilles subduction zone. The margins of the clip have been uplifted and are exposed above sea level, which makes it unique among oceanic plateaus. It stretches 2,500 kilometers east to west and 1,300 kilometers north to south. The clip is composed of irregularly thickened oceanic crust of the Caribbean Plate and the deformed associated magmatic terrains abducted onto the Pacific coasts of North and South America, Central America, and the Antilles. One of the least deformed parts is Gorgona Island off Colombia's Pacific coast. The clip was created during 3 phases of eruptions dating between the Aptian and the Maastrichtian. The first phase, 124 to 112 Ma, the main magma production phase 94 to 83 Ma, and an 80 to 72 Ma phase. The youngest igneous rocks, in the Dominican Republic and Costa Rica, are from 63 Ma. That the clip originated in the Pacific is obvious because fragments of oceanic crust accreted to the margins of the Caribbean. For example, on Hispaniola and and Puerto Rico contain fauna of Pacific provenance. The Farallon Plate's eastward movement forced the northern half of the clip into the ocean basin that had opened between North and South America, starting in the Jurassic. However, the mechanisms causing the knee movement of the clip remains unclear, especially considering the subduction in the Costa Rica-Panama arc initiated during the Campanian. The Galapagos hotspot is probably responsible for the main plume-related magmatic event 90 Ma, whilst the 76 Ma and 55 Ma event are related to lithospheric thinning in the central Caribbean. 40-39 dating have determined that the main magmatism occurred 95 to 83 million years ago, while a second pulse occurred 81 to 69 Ma. Around 86 Ma, the arrival of a large plume initiated the Galapagos hotspot, which resulted in volcanism over large parts of the Caribbean plate and northwest South America. Renewed volcanism about 75 Ma has been attributed to either the Galapagos hotspot, thinning of the lithosphere coupled with associated melting and upwelling of plumehead material, or both. Seismic and geochemical analyses, on the other hand, suggest the clip consists of several oceanic plateaus and paleo-hotspot tracts formed 139 to 83 Ma, some of which have been overprinted by later magmatism. If these first volcanic activities were generated by the Galapagos hotspot, it would make it the oldest still active hotspot on Earth.